So today we will look at how to perform division by 3 using a DFA. So first of all we will look at what a DFA is. So we will not go into the details of that, but we will have a brief introduction. So DFA stands for deterministic finite automata. So what it means, let us try to explore. So first of all, it's finite, not infinite number of states. It's an automata. What an automata is and what deterministic means. So first of all, an automata consists of states. So this is state q0, q1, q2. So it is a kind of machine. Our machine is in state q0 in the beginning. So this arrow represents the start state. So our machine is in state q0 at the beginning. If we get 1 as an input, our machine goes into state q1. If we get a 0 as an input, our machine goes into q2. And from q2, if we get 0, then our machine goes into this state. This is like this. So why it is deterministic, I am saying, because if a 0 comes in state q1, it goes for this transition and comes to q0, and if a 1 comes, then it goes to q1. So it's well defined. It's not like this, like on a 1 it can go to q1 and q2. So such kind of transitions, like for here also, so this kind of transitions are not present. So it is a deterministic decision that if it inquires a 1 on q0 state, it will move to state q1. Okay, so what these states are, like states of a machine. So let us try to I will give an analogy to make you understand this. So like q0 can be, let us consider this machine to be a car. It can be anything. So maybe car. This state is petrol, and petrol tank empty. So instead of this 1, what the input will be? Fill petrol. This will be the input, fill petrol. And in which state will we reach after following this transition? We will reach in a state where petrol tank is full. Okay, and this may be a state where car engine started. So when we have filled petrol, what next we want to do to start the car engine? We rotate the key. Rotate key clockwise or maybe anti-clockwise, whatever. How to stop the car? We again rotate the key anti-clockwise in the opposite direction. It stops the car. The petrol tank still remains full. Okay, so these kind of transitions might be there in a real world example, but for us the kind of transitions will be like this. Okay, so now this is a finite state machine, or a deterministic finite state machine, or automata, whatever you say. So how we are going to use this finite state machine to perform division by 3? So what we do is, whatever number is given to us, we are given the number, let's say 9. So what we do is, we convert this number into its binary form. That's the first step. So 9 will look like this in the binary form: 2 power 0, 2 power 1, 2 power 2, 2 power 3. So this will be the representation of 9. And then what we do is, we keep on giving the bits as input to this finite state automata one by one. So first we will give this bit as input, then we will give this bit as input, then we will give this bit as input, then we will give this bit as input. Okay, so initially it is in state 0, and finally if it is in the final state, so this state represents the number which are of the form 3a. This state represents the number which are of the form 3a plus 1. This represents number of form 3a plus 2. So in whichever state it lands finally, that's your number. So 1 takes me here, then 0 takes me here, then again 0, it takes me back here, 1, it takes me back here. I am just following the transitions, you can note. So finally, after all the bits have exhausted, we are in this state, which is representing the numbers of form 3a. So our number is perfectly divisible by 3. So 9 is perfectly divisible by 3. We can conclude. Let us consider another example. Let's say 10. So what will be its bit representation? 1 0 1 0. We give 1. Initially we are in this state because this state is marked as the start state. Because when no bit is given, then we assume the number to be 0, which is of the form 3a. So 1, I'm just taking 10 as input. 1 0 1 0. So finally I land at Q1. So 10 is of the form 3a plus 1. So it is not divisible by 3. It leaves a remainder of 1 when divided by 3. Okay, so how do we arrive at this finite state automata which we are using to detect the form of the number? That is the remainder on division by 3, or detecting whether it is perfectly divisible by 3. How are we drawing this automata? Okay, so drawing this automata is quite simple. We just consider all the cases. Let us consider the first case where the initial state is Q0, that is the number is of the form 3a. Now I can provide a 0 as the next bit of my input or a 1 as the next bit of my input. So if I provide a 0 as the next bit of my input, then what is going on here? Let's take this example. 101 has already been provided. Now I provide 0. So this 101 has shifted to the left by 1 position. So this 3a, the number was initially 3 of the form 3a. So 3a has shifted left, that is 3a multiplied by 2, and this bit is 0. So 101 has shifted left and we have appended a 0. So this 0 doesn't add anything. So this number becomes 3a multiplied by 2 from 3a, that is 6a, which can be 3b. So it is also a multiple of 3 if b is another number. So it is of the form 3b, which is another again in Q0. So if we encounter a 0 in Q0, we remain in Q0. If we encounter a 1 in the state Q0, what will happen to our number? 3a will shift 1 position to left, so 3 into 2, and plus 1. Like 100 has already been there and we are encountering a 1. So this 100 will shift left by 1 and this 1 will also come. So 3a into 2 plus 1, that is 6a plus 1. Now replacing 2a by b, we get 3b plus 1. So which is represented by the state q1. So if we encounter a 1 in state q0, we get to state q1. And similar are the other calculations. Like in state q1, which is of the form 3a plus 1, if we encounter a 0, 3a plus 1 into 2, that is 6a plus 2, that is 3b plus 2, that is q2. 3a plus 1, 1, that is 3a plus 1 into 2 plus 1, that is this, that is finally of form 3b. And similarly for q2, these are the two cases. So finally, if we stop at q0, the number is divisible by 3 because q0 represents the numbers of form 3a. Finally, if we stop at q1, the number leaves remainder 1 on division by 3 because q1 represents the numbers of the form 3a plus 1. And if we stop at q2, the number leaves remainder 2 on division by 3 because q2 represents numbers of the form 3a plus 2. Thank you, friends.